Thanks again for joining us, Mark. What a great conversation we had about hydrogen reuse. It's a strong reminder that closing industrial loops is critical for real sustainability. If you want to learn more about Skyre, visit their website and see how their innovative compression technique is transforming manufacturing across multiple sectors. If this episode sparked your curiosity, which I hope it does, don't forget to subscribe, leave a review, and share it with someone who cares about industrial climate solutions. See you on the next episode of Green Disruptors. This podcast was brought to you by Mountaintop Social Marketing, helping companies in sustainability scale. All right. Hi, Mark. Thanks for joining us today.
Hi, Megan. How are you doing today?
Doing really well. Tell us, first of all, where you are in the world.
I'm in East Hartford, Connecticut in the U.S.
And are you like a lifer there, or have you moved around?
I have not moved around. I've only moved about 20 miles from my hometown in my life. My only time away was up at school at Rensselaer Polytech in Troy, and we do have a second home down in Florida. So now I'm between the two areas. But yeah, growing up and working, I've always been in the greater Hartford area.
That's nice. It's nice to have that connection to home. I actually live in the same zip code I grew up in, which is crazy. But anyway, I didn't think it would end up that way. But
That's a
anyway, tell
song,
us.
that is definitely song lyrics, country song lyrics.
Yeah, for
Yeah,
sure.
yeah,
Back in your own backyard, that's an old jazz standard too.
yeah.
But anyway, yeah, so we're here to talk about Skyre. So tell us about the company a little bit.
So Skyre has been around for about 18 years, and it started by a colleague of mine, Dr. Trent Bolter. We've worked together on and off for about 30 years. Our career has overlapped now for the third time. And so it was founded after Trent obtained his PhD in materials engineering from the University of Connecticut. And he had a background in this technology going back to his graduation and his first job. And so in his garage, he started this company originally called Sustainable Innovations, eventually renamed Skyre, with the idea of taking hydrogen that exists in manufacturing areas that's being used in a process but not consumed in a process. And what he realized is that a lot of the hydrogen that's created in the world is wasted because once it goes through the process, there isn't an effective way to clean it up and recycle the 99% of the gas that isn't consumed back into the beginning of the process.
So they're only using 1% of it.
Sometimes even less.
Gosh, that's crazy.
Yep. So go ahead, ask your next question.
Oh, you continue.
Lead me along.
Yeah, so tell us, that seems like people have been doing it that way for a long time. How did you come up with innovations around that?
Well, what we did is, I should kind of start back at the beginning. And really, this technology that we're using today has had many applications over the years. And it started way back in the Gemini space program as a technology and a fundamental material called Naphion or Naphion, depending on how you want to pronounce it, which is this unique material which looks like plastic but has the ability to act like battery acid. So it's basically a solid form of acid. And with that, you can do the same kind of electrochemical processes that batteries do. In our case, the most common usage for this is actually in the chlor-alkali industry, used extensively in that. But some engineers at GE at the time in the 50s realized that this could be used to take hydrogen and oxygen, combine them together, one on one side of the plastic, one on the other side of the plastic membrane. And when they combine at the membrane, if that membrane has also got a little electrical catalyst on it, it becomes a battery. And so this was making water, which today is really important. In the early days of spaceflight, it wasn't important. important to have a drink, but it was important to have electricity. And so they used it as a fuel cell in the early Gemini programs. Later on, even like on today's space station, there is a system that's taking the water from the atmosphere and turning it back into oxygen so that the people can breathe. So this whole idea of either combining hydrogen and oxygen to make water and electricity, or using water and electricity to make hydrogen and oxygen, is a completely reversible reaction. In our particular case, what we do is we feed dirty hydrogen on one side, and instead of splitting it from water, well, it's already been split. So all we have to do is separate the hydrogen from the dirty gas. And what is hydrogen? Hydrogen is a proton and an electron. The membrane passes a proton across, the electron sneaks around through an electric path, shows up on the other side. Now your hydrogen moved from this side to that side, and all the dirty stuff stays on this side. And even the more beautiful thing is that membrane then becomes a compressor. And so if you can figure out how to electrically connect and structurally connect that piece of plastic, which is really kind of like about as thick as your contact lens, we can put thousands of psi of gas across there, electrochemically purify and electrochemically compress that gas. And so that's the fundamental technology that we've really exploited. We've taken the technology that was used in other areas and really optimized it for this cleanup and compression process. But electrochemically, it's a pretty simple, basic chemistry process. No magic. The magic is in the mechanics of doing it.
Yeah, that's fascinating. And I will just make a side note to listeners. If you are listening, you should go on YouTube and watch the video version because Mark has got some really great hand motions that honestly, for a visual learner like me, really helped me understand that. So thank you. I can tell you're an expert about talking about it as well as knowing what you're talking about. So
Thank you.
okay, so you did make it sound so simple. So what now that you've done this, then what?
So then it's go commercialize it, talk to people in what we call our target markets, and see whether the early adopters, actually want to adopt this technology. So two of the areas we focused on, one was the metals industry. And you're like, what is the metals industry doing with hydrogen? And what happens is there's a couple of times in the final processing of metals, and whether it's like shiny, bright, they call it bright annealed stainless steel, strip steel. The process that makes it shiny is to heat it and get rid of the oxidation on the surface. Well, how do you heat it up and keep the oxygen away? What you do is you flood the furnace with hydrogen. And you're like, what? You've got this furnace and you're filling it with an explosive gas? Yeah, you are. But what you've done is you've kind of put it in the exhaust area where most of the oxygen is gone. And then what oxygen is left is mostly in the form of water and oxides. You heat it up, you add the hydrogen, and the hydrogen scavenges that oxygen and turns it into water vapor. And it gets carried out of the furnace. And they want really pure hydrogen to come in so that it can go scavenge that. They can't recycle it back unless they could clean it up. So most furnaces, whether it's what they call the powder metallurgy or this bright annealed stainless are just two examples, they're venting tons of hydrogen each day because they don't know how to recycle it. They have no choice. The other big user is all your very complex chips today are made on a machine that's called an extreme UV, ultraviolet light, lithography machine that goes and prints that little pattern on the chip. And in order for that machine to work and that technology to work, they use a tremendous amount of hydrogen. I mean, the the pipes and the plumbing and the amount of gases that are used to make the teeniest chips in the world, these machines are huge. And so again, they're using the hydrogen to keep the mirrors clean in the system, to take out contaminants that get generated while they're creating this UV light, this extreme UV light, and they have to pull it out of the system at very high velocities and very low pressures. And the problem is also the low pressure. So they actually run at almost a vacuum, but it's still a tremendous amount of hydrogen. To pull that hydrogen through the machine, they have to make it thicker because it's really hard to pull such a thin gas. So they add nitrogen to it to thicken it up so they can pull it through the pumps. And now they've got their beautiful, almost perfectly clean hydrogen that they just polluted with nitrogen. So again, we can take it through that same system, nitrogen and hydrogen. We pull off the nitrogen, let it go by, the hydrogen comes across, we compress it back up and give that to them. It's millions and millions of dollars each year of hydrogen are wasted in these machines with no way to recover it. It's their second most expensive commodity in producing chips.
Yeah, and with where we are with the rapid adoption of new technologies, like that cost is not going anywhere. Like the demand for that's probably just going to keep going up. So that's a cost problem. Well,
And
especially with,
it's a cost problem, and it's also an environmental problem because it's
yes.
kind of on both ends of the hydrogen stream, you're creating greenhouse gas. Most hydrogen is created by reforming methane, and so you're giving out a lot of carbon dioxide. And actually, if you don't burn the hydrogen itself reacts with chemicals in the air. It itself is a greenhouse gas if you don't burn it.
Yeah. Boy, so I mean, I see that as a huge opportunity, and I'm sure that's exactly what you were thinking. So
Exactly.
when it comes to scaling this up and implementing it, is this something that you go install into each individual plant that's using it, or how does that setup process?
Yeah, so currently what we learned with some beta testing that we did, that our customer base wants some flexibility on sizing, and so we talk about it in terms of kilograms per day. So a typical customer will want several machines that do about 1,000 kilograms a day. So, in English units, about a ton of hydrogen a day. You think, wow, hydrogen's really light. A ton of that has got to be tremendously huge. If you think of like your welding tank, your welding cylinder,
Yeah.
it has less than a pound of hydrogen in it.
Dang. Yeah.
Okay, so you can see each machine, each furnace is typically anywhere from 500 to 1,000 kilograms a day. And so you go to a big metals manufacturing plant, they'll have 20 furnaces. Boom. For every EUV machine that writes your chips, they could use one of these machines. And that's just two industries that we're talking about.
Yeah. So, I mean, you brought up your target market, obviously, the metals industry. Is there another one that you're going after too?
When we look at the big users of hydrogen and start to trickle down through there, the market gets bigger, grander scale. So we're kind of starting at, again, this 1,000 kilogram a day unit. But there's markets where it's 10,000 kilograms a day quantities. And these start to get into the early processing of iron. The direct reduction of iron process, DRI process, could really use a multi-acre scale installation of
Wow.
hydrogen. That there's a process in there where we get some dirty hydrogen, reprocess it, send it back into the system. Glass processing, ceramics, hydrogenated oil, it's in there. Really, anybody who uses hydrogen can use one of our systems. Another interesting thing is this concept that's kind of recently been discovered called geologic hydrogen. And it's the idea people have discovered that there's actually naturally occurring hydrogen in many places. In fact, a recent article, I think it was New York Times, has identified there's 30 states in the US where geologic hydrogen may exist. And so you're like, well, why would you need your system, Mark, if it's already in the ground? The thing is that gas is mixed with other gases and it's low pressure. So if it's just kind of seeping out of the ground or buried in the ground like natural gas is, we need to be able to separate that out and then use that. So our system can separate that and pressurize it and get it to basically an economically viable, transportable gas.
Okay. Very cool. So let's kind of shift gears a little bit.
Sure.
Hearing about the science, I love science stuff. I'm not a scientist, but I love learning about it. But so when it actually comes to go to market strategy and making connections with these clients and the way that the business is profitable, um, where are you at in that growth journey and kind of what roadblocks have you run into?
What roadblocks? And where's the journey? So the first thing is to really cultivate those relationships with the users and to understand what they need. And this is what that whole beta process was. We demonstrated the technology, we put it into play. Some users used it, but we learned a lot of feedback about, like I said, scalability. Everybody's got a different size. So what we did in our new product launch is make sure that the product is scalable. If you want 100 kilograms a day, 500 kilograms a day, 250, 375, we can do it in smaller increments. And the other thing was, I'll say, easy to repair, easy to site, et cetera, et cetera. So we had to make it more modular, more portable, more siteable. And so that wasn't a change in the chemistry, but it was a
Right.
change in the packaging and the technology and the way the user interfaces with the system. So it's a re-engineering of the whole way we deliver this product and the way the customer uses it. So a lot of customer feedback and listening to the installer, listening to the executive, listening to the maintenance person, listening to the people who are using the gas that's coming out of our product, and lots of notes. That was good, that was bad, this was good, that was bad.
Yep.
And we took a whole room of Post-its and said, what's good, what's bad? What did people like? What did they didn't like? What do we need to invent to solve issues that people have? And we use, kind of some of these Six Sigma, Kaizen, take all your Toyota quality process words, and we used all those techniques to help us understand what was the voice of the customer, what was possible, what's profitable. And we actually learned by making smaller size units. Now our volume goes up on those units, and volume always brings price down. So building one large unit or something made of 10 smaller units, it's easier to repair, spares are cheaper, et cetera, and economies of scale go up, the price goes down. And so we'll have increments that are these acre size increments, but we'll also have sizes, say up to the 100 or say 1,000 kilogram is going to be all on one platform, 1,000 to 2,000 kilograms, all the way down to say 25 kilograms, same platform. And it's
That's
a
very
lot of
cool.
and it's a lot of the ways we thought about how are electric cars made. Electric cars aren't made with one big battery. They're made with batteries that are about this big, hundreds and hundreds and hundreds of them.
I did
And
not know that.
they used to be made with smaller batteries, but they didn't go and make one big battery because the economy of scale doesn't work there. So again, we took some of that learning
Yeah,
and used it.
that's fascinating. So what are those?
sales conversations like? I mean, are people like really eager to adopt this? What's the pushback? Like, how's that process?
People, all our customers want the system yesterday. Uh,
Yeah.
and so we're in the middle of this transition of the beta to the commercial product
Yeah.
that's high volume. We're selling that right now, taking orders on that. So
Hmm.
that's an item that we're selling, but delivery is probably of the first item is probably still about 9 months out, and we're filling an order book, on that, scenario at different sizes. In fact, just before your call, with you recording this session, I was on with a company working with some South America companies that want our product,
That's amazing.
and that one was a smaller size. So that one was only 100 kilograms a day. And so again, we take our replicable unit and give them a footprint, and give them a price and a delivery, and it's going really, really well. It's amazing.
That's great to hear. I mean, yeah, it's solving multiple problems and saving them a ton of money. So, um, how are people finding out about you?
Word of mouth, and when I say that, that's kind of the modern word of mouth. LinkedIn postings, seminars. People find us. I can't tell you how many times we get a phone call and they say, "We were talking to, boom, the Department of Defense, and they said we should call you. We were
Wow.
talking with some people at a Department of Energy conference, and they say you need to go talk to Skyre." You know, and so this happens all the time, and part of it is the reputation that comes really from our founder. As I said, he's one of the few people who learned this craft from the original inventors of the technology. It goes back of we started about the same time at United Technologies in different departments. I didn't meet him till 10 years later, but it was kind of like, "Hey kid, we need you to go up to the Boston area. We're acquiring a company. You need to learn everything you can learn about this technology and bring it from General Electric to United Technologies." And all the old timers now were near retirement and said, "Hey kid, let me tell you how you make these things. Hey kid, let me do this."
Pretty cool.
And
Yeah.
and so that's where our foundation goes back to. And this is fundamentally why we can do things that other people can't, because uh, Trent, over his career at United Technologies, Proton Energy, Nell, which he helped found 20 years ago. I worked for him then. And now Skyre, he's sold and produced more than 30,000 electrolyzers over his career. Way more experience than most other people have. Yeah.
Hmm.
And,
So
and
he's the leader in the industry authority there.
yeah, and and so this is fundamentally why we can do things other people can't, because we know the things other people don't.
That's a good position to be in.
It is very good. It is very good.
Well, that's exciting. I mean, there's definitely challenges that come with scale. Maybe we'll kind of wrap up the conversation by what do you foresee as the coming challenges in the next year as you really ramp this up?
I think it's going from a small company that originally did a lot of R&D to a company that's going to produce millions of dollars of equipment every year and service it out in the field, and the logistics that go around that. So we've got a few core people who have done high volume manufacturing. I'm one of them, our director of operations. But it will be growing that community and really go into a production mode, thinking about process control and Six Sigma and purchasing, strategic purchasing, and all these other things that come into play. So you're going to build out organizations for service and service centers and more
Hmm.
salespeople and more support people. Um, it, that's the challenge. Growth is the challenge. And really having
Yeah,
process behind you that everybody can learn on and adhere to the process is super important.
absolutely. Yeah, having good people who know what the best standard procedures are so that, as you grow, the quality doesn't go down and customers are happy.
Exactly.
It's a big
Yeah.
challenge though. That's
It
a
is.
lot
It
of,
is. Yeah.
you have to create a whole new company culture as well.
Yeah. We did it
Yeah.
before Proton Energy. I was employee 53 at Proton Energy, and today Nell's the largest electrolyzer company in the world.
You know
So
what you're doing. That's
we know what
awesome.
we're doing.
Okay, well, with your lab coat and your background, I'd probably just believe anything you told me.
Thank you. Thank you.
But anyway, thank you so much for telling us about this. I mean, I think to your average layperson, this is something we're completely out of touch with that don't even know is happening. And, if you're involved in climate, it's a huge problem that needed to be
It
solved.
sure is.
So I'm excited to see the impacts that are going to come from.
Megan, this was awesome talking with you today.
Yeah, thank you. I really appreciate you coming on.
Very good. Have a great day.
Okay, you too.
Yeah.
Thanks again for joining us, Mark. What a great conversation we had about hydrogen reuse. It's a strong reminder that closing industrial loops is critical for real sustainability. If you want to learn more about Skyre, visit their website and see how their innovative compression technique is transforming manufacturing across multiple sectors. If this episode sparked your curiosity, which I hope it does, don't forget to subscribe, leave a review, and share it with someone who cares about industrial climate solutions. See you on the next episode of Green Disruptors. This podcast was brought to you by Mountaintop Social Marketing, helping companies in sustainability scale.